Ba. Hello, chemistry. What's up? What's up? Today chemistry. We're gonna be doing skill practice 39. Um, it's mass percent, mole fractions, molarity, molality. So yeah, let's get right into it. Um, Number one, what is the mass percent of calcium chloride if 45 grams of CaCl2 is dissolved into 20 grams of water? So mass percent in Chem Quest 39 is solute over the whole thing. So in this case, we're looking at the solute of 45 grams. So it's gonna be C, so it's gonna be 45 over, and then it's solute plus solvent. So 45 plus 320 is gonna be 0.123. But you multiply it by 100, and then that will give you 12.3%. And number two, a solution that is prepared by dissolving 32 grams of salt and 278 grams of water. What is the mole fraction of salt? So as stated in the name, mole fraction deals with moles, but in the problem, we're given grams. Given grams. So we need to convert these grams into moles. So salt is otherwise known as NaCl. Grams of NaCl, 1 mole of NaCl. So the molar, oh, the mole fraction, no, the molar mass of NaCl is 58.45, and so that's gonna give us 0.55 moles of NaCl. And then for water, it's going to be 278 grams, and water is known as H2O. So grams of H2O, moles of H2O. So 1 mole of H2O has 18.8016 grams. This will be 15.43 moles. All right, so the mole fraction of salt. So we're going to focus on salt. So the thing we're focusing on goes on the top, 0.55 divided by um the moles of solute plus moles of solvent. So it's everything combined. So it's going to be 0.55 plus 0 plus 15.43. It's going to give us 0.034. All right, and then mole fraction of water, 15.43. That's what we're focusing on, the solvent this time, divided by 0.55 plus 15.43, 0.96. Number three, how many grams of calcium nitrate need to be added to 400 grams of water to make a solution that is 12.5% by mass of CaNO32? So here we're given the mass percent and the solvent. So we added. So it's gonna be grams of how many grams of calcium nitrate need to be added to 400 grams of water. So it's gonna be, in this case, the formula mass percent to find any CaNO32 is, we don't know what the grams of calcium nitrate is, right? Because that's what we're trying to find. So it's going to be, that's our unknown. right? And then over, we have our 400 grams of solvent because, and then on the denominator, it has to be, I think that's right, yeah. And the bottom has to be solute plus solvent. But in this case, we only have the solvent. So we need to add the solute plus X, right? So in this case, X is our solute. And then when you add this up, you multiply it by 100. Oh, actually, no, we'll skip that. Add this up, divide it together, you get 0.125. And the reason why I choose to do 0.125 instead of 12.5% is because they're technically the same thing, but to get 12.5%, it's just an extra step of multiplying it by 100. So, right? And to do this math problem, you to do this math problem, you multiply both sides by 400 plus X. 400 plus X. In this case, you're gonna get X equals you multiply this spot, you distribute, so it's this times that, and this times that. So 400 times 0.125 is gonna be 50, and then 0.125 times X is 0.125X. You isolate the X's by subtracting 0.125X by both sides. You're gonna get 0.875X equals 50. Divide both sides by 0.875. X is going to be 57 grams of CaNO3. Yeah, I think Ca, calcium nitrate, CaNO3. Sweet. All right. Number 4, we actually skipped that one. Yeah, because in the directions it says to skip number 4. I missed Lee. Number 5, if 325 milliliters of solution was prepared by dissolving 83.8 grams of Na3PO4 in 310 grams of water, what is the molarity of the solution? Right, molarity is moles of solute over liters of solution. In this case, we don't have moles of solute, we only have grams of it. So you need to convert grams to moles. You sneeze. 83.8 grams of Na3PO4. You do the molar mass of it, you just add everything together. It's gonna be 163.94. Divide this out, you're gonna get 0.51 moles. 3, 4. Right, so 0.51. It's your solute over liters of solution. We have 325 milliliters. To convert milliliters into liters, you move it 3 decimal places to the left. 1, 2, 3, 0.325. Divide this out, it's going to be 1.57 molarity. All right, B, what is a molality of solution? Molality is still moles of solute, but it's moles of solute over kilograms of solvent. In this case, our solvent is 300 water, so you have 310 of it. However, we only have grams of it. We need to get to kilograms of it. So 310 grams to kilograms, it's going to be 1, 2, 3. So 0.31 kilograms. Kilograms, and then divide this out, it's going to be 1.64 molality. All right, number 6. Describe how you can prepare 200 milliliters of solution that is 1.2 molar NaCl. So molarity right here. we need to find our solute or solute or moles of solute. So looking at the formula, 1.2 molarity is moles of solute over liters of solution. In this case, you have 200 milliliters of solution. We move it 3 decimal places to the left. 1, 2, 3, 0.2 liters. You isolate this guy. And then it's going to be 0.24 moles of solute. And the way this question asks is just writing it in words. Like, how do I do this? You can't take some moles of solute, so you have to convert it to grams. Honestly, I don't know why this problem's in here. It doesn't really make that much sense. So the solute is NaCl. You convert it to grams, so moles of solute, moles of NaCl. The molar mass of NaCl is 58. 58 something, 58.45, I think. It's gonna give us 14 grams. So in words, because to describe, I would say take 14 grams of NaCl and dissolve it in 200 milliliters of a solution to get 1.2 molarity NaCl, right? Because you take the grams of NaCl, dissolve it in the solvent, which is 200 milliliters of the solution, dissolve it in there, mix it up. That's how you get 1.2 concentration, molarity of NaCl. That is skill practice day 9 for you guys. Hope you guys enjoyed. Later. Good luck study. Woo-hoo. I love chemistry.